Hello everyone, welcome to my YouTube channel. This is 9 Victor 1 Hotel Yankee, amateur radio operator from Singapore. And today I'm making this video to show you about some of the preparation work I have done in order to work on QO-100 geostationary amateur satellite. As you may know, QO-100 is the first geostationary AIMSat in orbit. It was launched November last year. It has been in service for 1 year already. So as an amateur satellite operator, I'm really excited to see QO-100 launched, and I really wanted to work on QO-100. But because of some restrictions and difficulties, I wasn't able to do it until now. I can have the chance to prepare my station that can work with QO-100. So today, just want to share with you about some of the preparation work I have done and to show you about my plan and what I am going to do, what I have, what I'm going to purchase, something like that. So firstly, I'm going to talk about some difficulties I have. First difficulty is the geographical difficulty. Because Singapore is in Southeast Asia, and from this picture, you can see the coverage area of QO-100 satellite. QO-100 is located at 26 degrees east. So the coverage area includes all of Europe, Africa, half of Russia, Middle East, some Southeast Asia, some part of China, Middle Asia, and some part of Brazil. So almost half of the world is in the coverage area. From my QTH currently is in Singapore. From Singapore, it's almost at the edge of the coverage area. So the elevation is really low. From here to work with QO-100, we need to point our antenna directly to the west, 269 or 270 degrees. And our elevation is only 3 degrees. So you can imagine the antenna is almost pointed to the horizon. If there's any obstruction, then it's almost cannot work with the satellite. My hometown is Beijing, China. It's out of the coverage area. So from there, I cannot work. And within China, only the very west portion of China is within the coverage area. There are a few ham there that can work with the satellite. So far, no one has been work on QO-100 from Singapore, but we do have neighboring countries to work to have station that can work on QO-100. So coverage area and elevation is one of the difficulty. The other difficulty is about the frequency. Because in Singapore, due to the local regulation, by right we have S-band and X-band included in our amateur radio handbook. However, it does not give to us by default. We need to write some email and prepare some paperwork, indicate our purpose to work on the satellite. And also, to own a parabolic or dish antenna, we need some consent from the authority. I have been talking with the authority a few months ago, and they are actually quite nice, and they kindly offered me permission to own a parabolic antenna as long as I do not do what my license authorize me to do. So I will use the parabolic antenna entirely for QO-100 operations. I will talk more about equipment later. So frequency is one issue. The other issue is I do not have experience with microwave bands. Right now, I only have experience with HF and also with low Earth orbit satellite. Low Earth orbit, most of them is VHF and UHF. That's 70 cm. I do not have any experience above 70 cm. So this one satellite is 2.4 gigahertz and 10.5 gigahertz. So it is my first time. And so at the beginning, I did some research and did some readings to learn about how to really work on those QO-100. And I also watched video about other ham operators. They work on QO-100, and also they show their equipment setup. From there, I actually learned that there is really not much different from microwave bands and VHF, UHF, and HF. Basically, if you have your system, you have your communication link established and your system working, you can have basically it's an HF band 24 hours. So Now I am going to show you the system block diagram of my setup. This system block diagram is after a few iterations. Initially, the block diagram doesn't look like this. Initially, I wanted to use a normal radio transceiver with up converter for my uplink. However, the radio transceiver I'm having is ICOM IC7300. That's an HF plus 6 meter transceiver. So from there, the only option is to transmit on 28 MHz and up convert it to 2.4 GHz. It is also my first time to work with up converter, so there are too many uncertainties, and also 28 MHz to 2.4 GHz doesn't seem as reliable as 430 MHz to 2.4 GHz. So after some consideration, I abandoned that idea to work with SDR, because SDR is, first, it's easier to work, second, it's smaller in size, and also it has the ability to actually transmit and receive with the same time. Because if I use ICOM 7300, I also need another SDR for receiving only. So this time the SDR I choose is Lime SDR, because Lime SDR has a wide range from some kilohertz to 3 gigahertz. So I can have a direct output 2.4 gigahertz. And the receive is the receive after the down converting is within the Lime SDR range. And also Lime SDR allows full duplex when you both transmit and receive at the same time. Because it's quite important for satellite operators to listen to your own signal. Then you can determine whether your communication link is successful or whether there's any problem with your transmitter or receiver. So after the Lime SDR output, I will have an amplifier. This amplifier could give me 10 watt to 20 watt, at least 10 watt. From there, I will have a patch antenna. This patch antenna and LNB combination, I use the design that is quite popular among ham radio operators. That is a dual feed patch antenna together with LNB. And to use this, I can have both transmitting and receiving antenna pointed to the same dish antenna. So I can use the same dish for transmit and receive. Then for the receiving side, I will use a KU band LNB that is has a local oscillator of 9.75 MHz. So with this LNB, I can down convert the X band downlink signal to 739 MHz. That's for the narrow band. That's for the narrow band transponder. And after that, I will use the bias T to provide the DC current to LNB. Then the 739 MHz signal will go into Lime SDR and we try to receive from there. Yeah, this is the entire block diagram. It may change, but I don't think it will change a lot from here because I have already changed it quite a few times. So right now, after I talk about my design, my plan, right now I'm going to talk about what I am going to do later. So since last week, I started to purchase component from online and from locally. So right now I have this Lime SDR. This Lime SDR actually is a USB and also some RF connector here for transmitting and receive signals. And also I have a bias T. This bias T is from some ham radio shop from Europe. I purchased it online. Also the LNB. This is an octagon 2-port output LNB. Quite cheap and also quite convenient. The reason I choose 2-port because I really wasn't sure how many port do I really need. So 1 port may not be enough. I get 2 anyway. The price doesn't really change a lot. So with this setup, with all this equipment here, I am able to receive. Today, like this week, I am still kind of busy. So after a few days, I will test the receive. I also have some coax cable and RF connectors ready. So when I'm not busy, I will test the receiving only. This time, no dish antenna. I will just point the LNB directly to the satellite and see whether I can receive the beacon. Because there is CW beacon and PSK beacon in the narrow band transponder. And also DATV beacon from the wideband. I think I can receive at least the carrier. And also for DATV, I think other people's signal, I can also detect their spectrum. So if I can receive the beacon, I can really tell that first from my QTH, like the place I operate from, I can have a direct link to the satellite. Secondly, I need to test the frequency stability of the SDR, and also what is the actual range of the reception I'm going to have. If my receiving goes well, after the test, soon I will be going to China, and while I'm in China, I will settle the dish antenna and uplink amplifier, and I probably bring them back to Singapore and continue with the transmitting test. This time the patch antenna is not ready yet. Patch antenna I need to fabricate, and to fabricate I need to talk with my university. Hopefully they will lend me their lab and also their equipment to fabricate the antenna. If I get the antenna and dish ready, I can say I am good to have a two-way QSO on QO-100. So the timeline goes as this week testing, receiving. Next week, try to, if successful, then next week start to buy transmitting equipment. After that, by end of this year, if I can done with the transmit, latest by next January, I should have a two-way QSO on QO-100. So right now there has been no one from Singapore that works on QO-100. So really looking forward to be the first station from Singapore that works on QO-100 satellite. And we do have some neighboring countries such as Malaysia and Thailand that they worked on QO-100 before. So I asked them, then they provide me a lot of information such as what type of antenna they use, and also how big is the antenna, what's their power. So because we are quite close to each other and also our elevation are similar, so the value they give to me is actually a good reference for my station setup. Also, I post some of the questions on Twitter and in some Facebook groups. Many ham from Europe actually provides me support, and I really thank them. And I hope to work them on QO-100. And I would also like to thank everyone who watched this video and supported me. If you like this video and you want to see more updates from me, please subscribe to my channel. I also made ham radio related videos, mostly in Chinese, but sometimes in English as well. So if you want to see more about my operation or my experience in ham radio, please subscribe to my channel, and also also watch other video I posted as well. So yeah, that's all for this video. Thank you for your support, and I hope to work with you on air. 73, goodbye.